bring in the folders. You get your. I would prefer that you have your Scantron with you when you come to my office there. Well, I have it in my office there, but I won't be able. If you come to my office today, you look at the exam there, I won't be able to give the Scantron back to you, and you can take a look at it. Okay. All right, and we're going to do a little bit more calculation about involving molarity there. Okay, so this is the second example that we're doing here, and again, you have to know how we define molarity. Everything is pretty much tied to that definition. So, as I always put it, when you take this course, there are only two things you need to know. One is the definition, you have to memorize it. The other is the dimensional analysis. For dimensional analysis, all you need to do is be able to identify the correct conversion factor, plug them in, you will be able to get the answer. Okay. A third question here. The previous question was how many milliliter or liters of the solution will contain, say, 25 grams of a particular solution. Now, in this case, if you are preparing a solution, how many grams of solute do you need for a given amount in volume, in liters there, or milliliters? Okay, so this particular question asks you how many grams of potassium permanganate, KMnO4, is required if you try to prepare a solution with a concentration of 0.0125 moles per liter, and the total volume is 250 milliliters. And again, we go back to this particular equation. So in this case, the concentration is given 0.125 moles per liter, and again, moles per liter, this number has two quantities associated with it, moles and liter, okay, equals to X gram over 0.250 liter. Okay. Now you can't use gram by definition there. We don't have grams in the definition there. But the grams, that's the relationship between grams and the molar mass. Okay. So X gram times each mole for potassium permanganate is 158 grams. Okay. So if you set up equation like this, you will see who's Rn now. What's given? So this quantity is given, the molar concentration. Okay. And this quantity is given 250 milliliters. You've got to convert it into liters. Okay. X gram, and that's what the question is asking you, the N now. Each mole is equivalent to 158.0339 gram. So if you do the multiplication there, gram and gram cancels out. So X divided by 158 divided by 0.25 should equal to 0.125 moles per liter. And X is the number that you're trying to figure out. So step by step in solving that problem, that's, well, when you get to that point, and it's just algebra, and you can figure out the answer. So, and you would need roughly about 0.494 gram of the KMnO4, and you dissolve it in 250 milliliter water. That will give you a solution with this particular concentration. Okay. So again, everything goes back to how we define molarity, and this is the key that you need to. Well, it's an M. That's the key. That's the M word I'm looking for. This is the key that you need to memorize. Okay, molarity. You need to know how to define it. Okay. Another type of question involving ions from an ionic compound. Ion concentration from an ionic compound when you dissolve it into in solution. So if you have 5.15 gram of, what's the charge on the iron in this formula? Positive or negative, first of all? It's a metal, it's supposed to be positive. NO3, that's one of the 16 polyatomic ions. Nitrate, nitrate bears one negative charge, so what's the charge on the iron in this formula? 1 positive, 2 positive, 3 positive, 4 positive? 3 positive. So see, whatever we have talked about so far has something to do previously, whatever we have talked about, has something to do with the things that you will see in the future there. So make sure whatever you have already memorized, make sure you hold on to it. It's yours. You pay for it. Okay, I want you to hold on to it for the rest of your life. Don't ever give it back to me. I don't want it back. Okay. So what's the concentration for the nitrate ion in this question? Well, again, everything goes back to that capital M. We got to figure out the molar concentration of solution first. And the nitrate ion, this is something that you need to pay attention to for something that's water-soluble ionic compound. When you dissolve iron nitrate into the solution there, okay, so that's the balanced equation there. And every mole of iron nitrate will give out 3 moles of nitrate ion because of this number outside of the parentheses. You have 3 moles of nitrate ion. So when you do calculation there, you have to figure out what is the molar concentration for nitrate, iron nitrate first. And then the molar concentration of iron nitrate times 3 will give you the concentration of the nitrate ion. Okay, so we need to figure out the molar concentration, number of moles of the iron nitrate. So Fe 56, nitrogen N 14 times 3, oxygen 16 times 9. You add everything together, and iron nitrate, the molar mass is 241.188 gram per mole. Okay, with that information there, we can figure out 5.15 gram of iron nitrate. How many moles do we have? The conversion factor given. Dimensional analysis. So 5.15 gram times 1 mole on top, 242 gram on the bottom there. So you divide 5.15 by 241.88 and you get 0.02129 mole. Okay? Once you get the number of moles, you calculate the molar concentration. Total volume is 150 milliliter. Volume has to be in liter. So 150 milliliter times 1 liter is equivalent to 1,000 milliliter. So divide 150 by 1,000, you get 0.15. Okay, and 0.02129 divided by 0.15, you get 0.1419 moles per liter. The question is not asking you, this is the concentration for the iron nitrate for the compound. Okay. The question is asking you, what is the concentration for the nitrate ion? 3 times that number, and that will give you 0.426 moles per liter. Okay, so this is another type of calculation that you will see in your homework, and I guarantee you will see similar type of questions in your upcoming exam there. Not on this Thursday, but next Tuesday. And so you need to make sure that you go through the practice and homework there so that you know how to do calculations. Now, when we introduce the molarity there, we're introducing a new conversion factor with a lot of possibilities. Okay, and one of them is dilution. Now, when you do a dilution process, you are adding only solvent to a solution. Okay, you're taking a highly concentrated solution, put it into a larger container, and you're going to dump more solvent in there, most likely in household activities there, and that solvent will be water. Okay, so when you have what we call a stock solution in chemical storage room there, a stock solution has a higher concentration. Now, when you do the dilution there, one thing you need to remember, if you take certain amount of stock solution out, the number of moles of chemical dissolved in that stock solution is fixed.